What up everyone, this video is going to be the genetics video. To over my Golang career, basically in the beginning, it's like, I think it's almost 10 years ago when I started Golang, we were basically begging the Go creators for genetics. Because we have interfaces and everything, but we didn't have genetics, and people were actually begging to release genetics. And now that genetics are there, I think was Go 1.8, 1.7, not quite sure. Correct me if I'm wrong. Now that it's out, now that Go has genetics, I never rather use them, right? Because I think genetics is, again, it's a way of making your programs more complex. And I'm, like you know, I'm basically the master of simplicity. I like simple things, right? Simplicity is so nice to have, right? Simplicity is it's just amazing, right? But there are some cases that genetics can be useful, right? Because people try to overuse them. That's bad. But sometimes genetics are really, really good, right? So let's cover this. And we're going to use genetics probably in one of our projects for sure. But like I said, I don't use them too often. So I'm going to give you one of the use cases I'm always using them, right? So basically genetics. So why do we need them? Well, very simple. Let's say we want to make a custom map, right? Sometimes I do that. So we're going to say type custom map. And that's going to be a structure, right? And inside of this custom map, we're going to have the data itself. And the data is going to be a map string integer. Why? Maybe I want to make a custom map because I want to, I don't know, I want to map usernames with their age or something, or usernames with their ID. I have no clue. You tell me. So we're going to have a custom map. So basically we're going to make a new map because we need to initialize the data, right? So we're going to say new custom map. And that's going to be a pointer to this custom map here. And we are going to return the pointer to the custom map. And we're going to say that the data inside of this map is going to be make me a map of string, a map to integers, just like this. Pretty fine. And now we're going to implement a method or a function basically into this map. And what are we going to do? Well, what do we want to do with maps? We want to insert values, right? So we're going to say func m from map, pointer to a custom map. And these pointers, guys, I'm going to cover them. In the next episode, it's going to be pointers. And then we're going to have tests. And then we are going to go a step higher. We are going to cover concurrency in Golang, which is amazing. And when concurrency is done, then we're going to start our projects. Woohoo! JSON API, microservice, and all the shebang. It's going to be amazing. Yeah, it's not over yet, guys. It's not over yet. It's going to be a lot of hours. A lot of hours. You're gonna watch my face and hear my voice. You know what I mean? You're going to see me more than your girlfriend if you have one. Actually, it's better to have not have a girlfriend because there is no time. Nobody time for the shenanigans. All right, so my custom map insert. So if you want to insert something, we're going to say, because it's a map string integer, we're going to say insert the key, which is the key is going to be a string, and the value, v, is going to be an integer, and we're going to return maybe an error or something, I don't know. So we're going to return null because there is no error in our case, but it's always a good practice. And we're going to say mdata key equals v. Very simple, right? The problem is, we have a big dependency again, and the dependency is basically our map because it's a string int. If you want to change this, we can't, right? Maybe we want to have a cool map that does something special, and we want to reuse that map, but we can because sometimes you're going to have other data types. In this case, it's a string int, but maybe it's going to be whatever. I don't know. It could be anything, right? So how can we fix that? Well, you guessed it right. You're going to fix that with genetics, right? Let me drink some coffee here real quick. Delicious. All right, so we're going to make this generic. How we're going to do that is, like I said, there is no teaching. Well, there is a little bit teaching here, but it's a lot of syntax, right? And after 50 times, you're going to know that top of your head, right? So we're going to say type custom map. And if you want to do some generics, we need to provide these brackets here, right? And we're going to say, you're going to provide our types, right? In these two brackets, you're going to basically provide your generic types. First of all, we're going to have, what the hell is going on? First of all, we're going to have k from the key, and the key can be anything, but that's not true. It's true, but we need to say that it's going to be a comparable. Why? Because a key in a map is very important that it can be compared. Why? Because you're going to probably, the internal implementation of a hash map is where you're going to have a key. That key is going to be hashed, and then you're going to be compare these keys to each other to see if it's already exists in a map or something, right? That's the thing. So we're going to say that K, capital K, is going to be a comparable. And then we're going to say V is going to be the value, and that's going to be anything, right? So we could say any, right? So we have a custom map where the key is a comparable and the value is an any type, right? So our data is going to be a map of K map to V, right? That's the thing. That's already been done, right? So we're going to have a custom map. We're going to have a custom map of K comparable and V values. That can be anything, right? And then we're going to say map KV. Done. All right, then we have this new custom map, which basically throwing a lot of errors at us. So we're going to fix that. So what we need to do is we're going to specify this once again here, these brackets. And we're going to say K is going to be a comparable. And V is going to be a type of any. Then we need to go to this guy here. We're going to say, again, these brackets, KV. And then here, again, these brackets, KV. Right? And then here we could say string int. We're going to change this to KV. What's going on here? Boom. So that's done. It's a lot of syntactic things. It's not something I can teach you. It's something that needs to be it like this, right? There is no thing. It is like that, right? It's just syntax. Do it 50 times. You're going to know it at the top of your head. Easy fucking peasy. So insert is going to be string int. That's not true. We're going to say custom map of KV. And we're going to insert K, which is going to be K. And V is going to be exactly V. And that's it. And we're done. So right now we could say here, let me say map M1 is going to be a new custom map. Custom map. Can I not type anymore? What's going on? I cannot read. It's going to be a new custom map like this. But we need to specify the type. So we're going to say a custom map of... do we need it like that? Yeah, I think so. So we're going to say a custom map of string and integers. And then we could say M1 inserts, let's say foo and foo1. And you could say M1 insert bar is going to be 2, right? That's a custom map of string integer. That's how you initialize them. String int. It's the same thing. You could see these things here, K and V. That's basically these variables here. And you could specify much more values, right? That's something you can infer, right? So we could also say M2 is going to be a new custom map. And that's going to be a custom map of, for example, a map of integers to floats. 64, so that can be perfectly fine. So we're going to copy, we're going to say M2 insert, and we're going to say 1 is going to be 9.99, something like that. And we could say M2 is going to be insert again, and that's going to be, I don't know, 100.333 or something, right? This is a problem here. New custom map. You see, that's basically generics, right? And there is nothing much to it, to be honest. It's just specifying the syntax here, and you could do it in functions. You could do it whatever you want, right? So let me give you an example of a function, maybe. Let's say func. Let's say func foo, for example, like that. And we're going to say func foo takes in a generic thing. For example, let's do this, fmt println v. We're going to print v here, or value. And we're going to say foo takes in a value, which is going to be an any. And then we're going to say wait, it's going to be v. Let's say t any, val t. And we're going to print the val here, right? So let's delete everything inside, change inside this thing here. And we're going to say foo, and we're going to say foo of integer, and we're going to say 1. Well, it can infer this, it's fine. Sometimes generics can infer the type, right? Because we don't need to specify int. It's gonna work, right? You could do make go run main.go like this, boom, and it's gonna return us 1. You can see that in the console. But you could also say string here. We could also say nothing, like this, foo1, and run again. And it's gonna be perfectly fine, right? Because it can infer. Sometimes it can, sometimes it can't. It's something the type hint will show you. So we're going to say foo of a string. So we're going to say foo agg or something. And then we're going to print that out. And you could see it prints out agg. And again, unnecessary type arguments. We can delete the string and it's going to work perfectly fine. You see? Bam. That's basically generics, guys. Hey, and you can have multiple arguments, right? You could say t, b is going to be an any again, right? You could say val x is going to be b, right? And not enough arguments, so we could say 1. And you see it's working pretty fine like that, right? But you could also specify it's going to be a string and an integer, right? It's going to work, but it's basically to verbose. You can unnecessary type arguments, you can delete it. This is generics, nothing more to it. Don't really think you need to master generics because you don't. Most of the time, if you really want to implement them, it's you have this in the back of your head, so you have something you can fall back to, and in worst case scenario you can look it up. But it's not very important, trust me, because I don't really use them that often. I don't think it's needed. Like all my big projects I built on YouTube, basically never use generics. Sometimes maybe a map or something like a concurrent save map or some helper stuff. But that's basically, I'm using these syntaxes, right? So if you know this, you know basically a lot, right? So don't worry about it. And yeah, generics, no big of a deal, easy peasy. Hey, thanks for watching and I'll see you in the next video. Bye-bye.